Hello all, we are the team from NDT Consultancy and Training Center, and we're also having a NDT services company named Baba Inspections and Technical Services Private Limited. Here we are with an introduction video which gives an overview about what is NDT, why NDT, eligibility for NDT and our placement programs, and also we discuss about NDT methods, their applications, in different industries and certifying bodies and value of certification. And for more information you can also contact with us, and the contact details is also given in this video. Okay, moving to the first thing, introduction to NDT. NDT means non-destructive testing. By observing the name you can get a small idea about what's happening. Like, observe the name NDT, non-destructive testing. Here you can find three words: non-destructive and testing, right? So observe the thing, like here testing means the process of examining to find out the capability or to find out the faults within anything. Like, take an example as students and their semester exams. So here semesters for students, these helps in finding about how much the students has learned at the end of the year or syllabus, or and how capable he is. And like, moving to the one more example, like, take a healthy person, and a healthy person, he works actively throughout the day and gives best output. But when he is affected by any diseases like fever, flu, malaria, and some other diseases, etc., his performance reduces. So like, yeah, like due to its inability or due to the diseases, his performance or his regular output gets reduces. So here the diseases are the cause for the reduction of performance or performance reduction. So like, so these are the some, like, these diseases are some, like, are cause for their reduction in output or reduction in results. So now coming to the point of treatment, like coming to the point of treatment of a person, like, to find out the abnormality with the persons, initially the doctors refers for some tests like blood test, urine test, etc., like, which is used to find out the reason for the performance reduction. Like, we're not confirmed with the thing that it is a malaria, that it is a diarrhea, like by observing the person we wish to, like, to confirm about the disease what he is suffering with. Initially we have to perform, like we have to test the persons, like by, like, uh, by blood test, urine test, and etc. So by observing the results what has obtained in the blood test and urine test, we, like, we used to confirm with the thing what, with what disease that the person is suffering with, and we used to provide the medicine, like, ways to use the medicine according to the related disease. Similarly, like coming to the point of materials, there are also some factors which reduces some materials performance, and those factors are called as defects. And like, these defects affects the quality of the material, like, these reduces the quality, like, something else. So these affects the quality of the material. And there are many reasons, like many types of tests among, like, there are many types of tests to find out the abnormalities or to find out the defects within the material or to find out the things which reduces the quality of the material. Like, among the many tests, like, chemical test, there are chemical analysis, there is a metallography test, there is a destructive testing, non-destructive testing, and so on. There are many tests. Among all those tests, destructive testing and non-destructive testing is used most to find out the quality of the material. And the difference between the destructive testing and non-destructive testing can be clear by observing the name, like name of the both things, destructive testing and non-destructive testing. Like, observe first thing, observe the destructive testing. So DT, destructive testing, it means, like, it is a type of test to find out the quality of a material by distracting or by destroying. So here in this test, we wish to find out the material's quality by destroying the material or by changing the shape of the material. Like for example, you can have a general examples like right here: tensile test, compression test, bend test, and so on. These are the some methods of testing which relates to the destructive testing. Now, taking an example as a bend test. So it is one of the destructive testing methods, and which is used to find out the capability of a material to bend. And here we observe the material or sample by bending it. So it means that the sample shape changes after the test has completed. So what we used to do in bend test here, we used to bend the material or like to find out the capability to of the material to bend. So after it means that after the test has been completed, the material what we have taken gets change of its shape. So like it may be get destroyed or it may be get it may be get shape change. But coming to the point of non-destructive testing, then non-destructive testing, the name explains the thing. Non-destructive, it is a type of test which relates to non-destructive. That means that here non-destructive means not destroying without destroying. So here we can get the quality of the material without damaging or without changing the shape. So it means that we can use the material even after the test has done, but wherein destructive testing, the material on which we have performed the test cannot be used. So in destructive testing, the material what on the sample on the material on which the test has applied or test has performed cannot be used further. But coming to the point of non-destructive testing, we can also use the material on which we on which we have performed the test. So you can have a look at here. Definition of NDT: any method for examining an object or material in any manner which will not impair its future usefulness is known as the non-destructive testing. Simply testing without destroying. So it means in non-destructive testing, the material which has tested cannot be get destroyed, right? So I think it's clear for you all about general difference between the destructive testing and non-destructive testing. Next, why NDT? So why NDT? Discussing about the thing about why NDT. Uh, Non-destructive testing used to detect internal and external flaws, or it means it is used to detect the internal and external discontinuities, used to measure the geometric characteristics. It means that non-destructive testing is also used to find out the length or thickness or something else based on the geometric explains the used to measure the geometric characteristics. And it also used to determine material structures or composition. And it also used to measure some of materials properties, right? So next, NDT evolution is used for. See, in any production, we're not conform with the thing that every material which is manufactured is perfect. So there may be some defective pieces, or there may be some there may be some defective pieces in the manufacturing during the process of manufacturing, and these defective pieces are cause for loss of safety during its working. So here, and it is used to find out the defective materials in within the company, and increasing the safety by not allowing the defective pieces to outside for working, right? So you can have a look at here. Entity evolution is used for increasingly in our nuclear and spaces, which some engineers have called the material says. North American industries becoming concerned with the need of non-destructive testing. No material is perfect, but it must have adequate properties to meet the increasingly rigorous demands made upon it. So NDT detects NDT is used to find out the properties of the material, and it also used to find out the defects present within the material, and also it is used to find out the performance and capability of the materials or parts or assemblies or equipment or structures without impairing their serviceability or without destroying the materials, right? To the next topic. So here it has given about the applications of NDT. NDT is used in like almost in all the industries. Like here it has given some in the industries where the NDT is used most. So they are aerospace industries, aircraft, automotive industries, casting and forging, chemical and petroleum, construction, electronics, food processing, marine, materials joining, security, metals, non-metals, nuclear, ordnance, transportation and utilities. So maximum of all the industries use the non-destructive testing, right? Next, so discussing about the non-destructive testing, like now types of NDT methods. So there are many NDT methods. Among them, here we have, like in this video we used to discuss about the mostly used NDT methods. They are radiography testing, magnetic particle testing, ultrasonic testing, liquid penetrant testing, eddy current testing, and visual testing. Now let us discuss about each and every test one by one. Okay, right. First, radiography testing. Radiography testing. See, any test is named based on the inputs what we use. Like for example, uh, blood test. It is a type of test to find out the abnormalities of the person, or like to find out the here in blood test we generally use blood as a medium to find out the abnormalities of the person, hence it is named as a blood test. Similarly, coming to the point of any test, it has named based on the medium, like based on the media what it is used to find out, like to perform the test. So if you observe the radiography test, you can find it three words: radiography and testing. So testing is nothing but examining like examining or evaluating something else, and graphy means image, and radio is refers to the radioactive rays. So see, by observing the name, I think you get a small idea that here it is a type of test. Radiography test is a type of test which is used to find, which is used to find out the which is used to detect the discontinuities within the material by using the radioactive rays like X-rays and gamma rays, and by generating, like by using those rays passing through the material and generating the image of the material, and evaluating the image, like like here we judge the discontinuities whether present within the material or not. So you can have a look at here. So RT involves the use of penetrating X-rays and gamma radiations as source to examine parts and products for imperfections. Radiation is directed through a part onto the film. See, here you can observe what's the process is happening right here. So here we generally use the source, radioactive source, the point from where the X-rays or gamma rays gets released, and we used to place the material in front of the source, and we place the film at opposite of the source as like this, we place the material in between the radioactive source and film. Film is nothing but it is a recording media, like it's just a recording media. And here what happens, you can observe the thing. So here we pass the radioactive rays through the material, and these rays get impinged on the film after passing through the material, and due to the different intensities reaching the film, you can find the different densities within the film, and here we judge whether the material has discontinuities or not by observing the difference in densities in the materials, right? So look at here, when the film is like similar, see, it is a type of test similar to the x-ray, medical x-ray test. See, like um, what happens in the medical x-ray test, like for example, if there is any fractured part, they used to place on like on above a some recording media, something like film, and they used to pass x-rays through our part, and these x-rays pass through the part, like through the fractured part, and they get imping on the film. And after the film is developed, like the process of uh, like this is the process known as the film exposing. After the film get exposed, the film has moved to the developing. After the developing process, you will get a variation between the fractured region and unfractured region, and by observing the variation, just to judge whether the part has, like whether there is any fracture or not. The same thing we used to do right here, like here we used to pass the material, and like we used to pass the x-rays or cameras through the material, and we like these get imping on a film. And after developing, we used to observe the film and judging whether there is any discontinuity present in the material or not. So you can have a look at here. When the film is developed, a shadow graph is obtained that shows the internal soundness of the part. Possible imperfections show up as density changes in the film in much the same manner as the medical radiograph can show broken bones. I think like it will be clear with a basic working of a RT, like it's a small animation about basic working of a RT. So here I have taken like this is my material which has an imperfection in the center of the material, and I have placed the material in between the source, from where the X-rays and gamma rays gets released, and the film which acts as a recorder, or which acts as a recorder. So now I I allowed the X-rays and gamma rays to pass through the material, get reaches to the film. So the process is known as the film exposing. After the film has exposed, we forward the film for developing. After the developing process, you will the film get developed as like this. See, you can observe the variation right here in the shape of the same discontinuity which is present within the material. The reason is the reason to get variation in the film is, generally discussing about the film is generally similar, like in the initial stage, it means before exposing, it is gray or like similarly white in color, and it turns into the dark, and depends upon the amount of energy it reaches. Like it means if more amount of energy gets reached onto the film on a particular region, the region where the more energy more and intensity is reached, the region will becomes more darker, and the region where less amount of energy is reached onto the film will will appears as a lighter. So coming to the point of the material, so there is a material and there is some imperfection, such as something else, like a porosity or a pore or a shrinkage, something else, there is some cavity, like think as like there is some cavity within the material. So cavity is nothing but there, like cavity means there is no material in the region. So compared to the other regions, more amount of energy will pass in that region, so hence the region becomes darker. So by observing the variation in the film, we judge whether the material has discontinuity or not. I think you clear with the point what I am discussing, right? So next moving to the next thing, magnetic particle testing. So same thing, magnetic particle testing. So here you can observe the, here also you can observe three words: magnetic, particle, and testing. Testing is commonly, we have know the thing that is it's nothing but examine. And so by observing the name, you can get an idea that it is a type of test which use the magnets and magnetic particles as a inputs to find out the discontinuities present within the material or not. And in this test, like in RT compared to the RT can perform RT can be used to find out the discontinuities in all the materials, because they we generally use the X-rays and gamma rays as a inputs, and they have the capability to pass throughout the material. Like they are having the capability to pass throughout the material. But coming to magnetic particle test, here we can test only the materials which reacts to the magnets. So hence we can check only the ferromagnetic materials. We're not able to perform the magnetic particle test other than the ferromagnetic materials, because other than the ferromagnetic materials, they won't show, like the materials won't show any reactions for they won't show any reactions for the magnets. Hence we can check only the ferromagnetic materials. So magnetic particle test is done by including the magnetic field in a ferromagnetic material and testing the surface with the iron particles. See, let me explain what's happening in the magnetic particle test. Like for example, here in magnetic particle test we generally find discontinuities within the material by allowing, like initially we used to pass the magnetic lines of forces within the material. And like after passing the magnetic particles, after passing or allowing the magnetic lines of forces to flow within the material, um, like what happens right here, you can have a look at here. See, the magnetic lines of forces passing from one point to another point. You can have a look at here, right? There is a discontinuity right here. See, the presence of discontinuity in the passes region makes the magnetic flux or magnetic lines of forces to get leaked to outside. So it is known as the magnetic flux leakage. And the reason where there is a magnetic flux leakage will acts as a high attractive reason than the, like compared to the other reasons. So after the magnetic, like after passing the magnetic lines of forces or magnetic flux or magnetic fields in the material, we used to apply the magnetic particles on the surface of the material. And after we used to blow off, we used to blow off the magnetic particles by using a blower. But while you apply the magnetic particles on the material, these magnetic particles will get accumulated in the region where there is a more attraction force. It means that, like here, see, there is a leakage right here, right? So it is, we have already discussed the thing that the leakage, like due to the leakage, the region will act as a more attractive region compared to the other region. So the particles will get stuck in this region. So during blowing time also, the particles which is placed other than the which is placed in the other regions, other than the leakage region, will get blow off. But the particles within, in the region of leakage, will 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 not blow off, will stay on the material, and indicating that there is some discontinuity in the region, right? So surface and near surface imperfections will distort the magnetic field and concentrate the iron particles near such discontinuities, indicating their presence. So it means, if you, like while performing the magnetic particle test, if you find any reason as like if you find any magnetic particles get accumulated in any region, like any reason, so it indicates that there is some discontinuity in that region, right? So now you can have a general animation about working of the magnetic particle, general like basic working of magnetic particle test. So here I have taken a material which has a discontinuity in the material. So initially I use the magnet, here initially I apply the magnetic lines of forces, passes the magnetic lines of forces within the material. After that, apply magnetic particles throughout the region, complete region, and then use blower to blow off. So after using blower, the particles which is present on the region of discontinuity will stay, and the particles which is beside of the region will get blow off. So here the particles get stayed due to magnetic flux leakage, and indicating the accumulator region indicates the thing that there is a discontinuity in the region, right? So I think you're clear with the thing. So let's move to the next test, ultrasonic testing. So ultrasonic testing, in this in this also you can observe the three words: ultra, sonic, and testing. Testing means examine, and ultra refers to high, and sonic refers to sound. So it is a type of test. It is a one of the NDT method which is used to find the discontinuities within the material by using high frequency sounds. So in ultrasonic testing, we pass the high frequency sounds into the material which we want to test, and we wish to judge the materials, we wish to judge materials quality by observing the some reflections within the material. So generally UT uses the transmission of the high frequency sound waves into a material to detect the imperfections within the material and or changing the material properties. See, to understand the ultrasonic testing clearly, what's happening within the ultrasonic test, here I will give an example, general example, right? For example, see, I stood in front of a mountain and I have shouted, shouted for a shouted with a name or something else. So this sound travels within the air up to the region of up to the region up to the point of the medium change. Once the medium get changed, what happens right there? The sound gets reflected back. So the same phenomena get involved is used in the ultrasonic testing. So here we are having a equipment, and we can initially before performing the test we used to adjust the equipment, sounds velocity, sounds frequency, or sounds range, something else according to the material, and we used to pass the sound through into the material, and these sounds travels throughout the these sounds travels up to the region where there is no medium change. If there is any medium change, this gets reflected back and can be identified by in the CRT screen, which is a means to find out the reflections, right? See, the most commonly used ultrasonic testing technique is pulse echo testing. See, in ultrasonic testing, there are different types of techniques to find. There are different types of techniques pulse echo technique, through transmission technique, tandem technique, pitch catch method, and so on. Among that, pulse echo technique is most commonly used technique. Pulse echo technique is nothing but it is a type of technique in which the sound is passed and get received from the same region or same point. So see, pulse echo technique, wherein sound is introduced into the test object and reflections are returned to the receiver from the internal imperfections or from geometrical surface of the part, right? See, it can be cleared by the following animation. So basic working of a UT. So here I have taken a material. So here I have taken a material, and it is generally called as a probe, which is a means of generator of a sound. So see, I have set my setup I have set my setup according to this material. So see, the sound we allowed the sound to pass through the material. The sound travel throughout the material and it gets reflected from this point. The reason is see, from it is a point, it's sent to be as an interface, Interface is nothing but the dividing medium between the, like the dividing line between the two mediums. Here it is solid medium, and here it, like the outside region is said to be as a air. So hence it is a uh, uh, like there is a, like it means simply there's some medium change, solid and it is a air. So where the medium get changed, the sound gets reflected, or some of the sound gets also transmitted into the second medium. But due to the air, see, where there is a presence of air, only reflection occurs. So like it can be clear with the related topics. But the reason, you have to observe the thing that the sound travels up to the point where there is no medium change, and the sound gets reflected back from the point where there is a medium change, right? See, and the reflections can be identified on a screen, like which is called as a ultrasonic flaw detector, as a, as in the form of a echo, like how you can observe the thing, right? See here, I have said, and the sound gets started from the sound, and see, you can clearly observe right here. See, one more time, you can, you can observe clearly, right? See, the sound started, and when the sound received by the, like receiver or by the probe, it indicates with an echo, like it indicates with an echo, see, you can also observe an echo right here. It is called as the initial echo, and it is called as a back wall echo. Initial echo refers to the initial point of the material, and back wall echo refers to the last surface of the material. And by observing the thing, or by observing the thing, or by observing the thing in between these two echoes, can get the information about the discontinuities present within the material or not, right? So okay, next, discussing about the liquid penetrant test. Liquid penetrant test is nothing but it is one of the NDT method which uses liquid penetrance. Liquid penetrance is nothing but, here in liquid penetrance we generally use the liquids, which have the penetrating capability to penetrate into the open discontinuity. So it is mostly used entity method to find, to find out the surface discontinuities. And here in liquid penetrant test, the test object is coated with a visible or fluorescent dye solution. See, generally, uh, what happens in the liquid penetrant test, let me explain. I think, right, initially the material which we want to test by using the liquid penetrant test has to be cleaned properly, and then it is coated with a liquid penetrance which is of mostly of red in color. And after that we allow some time so that the liquid penetrance which has applied on the surface entered into the discontinuity, and after that we clean the region, like we clean the surface region, so that only the disc the only the penetrant is present in the region of discontinuity. And then we use one more liquid which is called as a developer, and the action of developer is used to read out the settled penetrant. And so once, when you have applied this developer, this penetrant get bleed out of the settled penetrant. So by observing the bleed out of penetrant, you can judge the thing whether, we can judge the thing that there is a discontinuity in the region. So see what has given right here. So initially the test object is coated with a visible or fluorescent dye solution. Then the excess dye is removed from the surface, and then a developer is applied. The developer acts as a blotter and draws the penetrant out of imperfections which are open to the surface. And with visible dyes, the vivid color contrast between the penetrant and the developer makes the bleed out easy to see. See, it can be clear with the following animation, or by the following picture. See, here it is it is my material, and there is a discontinuity present in the material. Initially I have cleaned the complete region on which, in the region where I have applied, where I am going to apply the penetrant. So then I have applied the penetrant, and allowed some time so that the apply like the penetrant gets settled into the discontinuity. Later I have removed the penetrant from the surface so that only the penetrant get settled in the discontinuity region. So later I have applied the developer and I have given some time to perform the developing action, and this developer brings out the penetrant from the settled discontinuity and makes us to view clearly, right? So it is the process of liquid penetrant test. And you can also look the following working by an animation. So here there is a material which has a discontinuity right here. So initially I have cleaned the material and then I have applied the penetrant, which is generally red in color throughout the region. So then I have given some time so that the penetrant get entered into the discontinuity. Later I have removed the penetrant from the surface, which is called as the excess penetrant, so that only penetrant like only the discontinuity has penetrant within it. Later I have applied developer throughout the region, generally white in color. When the developer has applied this developer, the action of developer is to bleed out of the settled penetrant. So you can like generally the developer is in white in color, and if the penetrant gets bleed out of the settled discontinuity, the reason where the penetrant get bleed out will appears as a red in color. It appears as a red in color. So it means if you observe any red color indication on a like after the application of the developer, so it means that there is some discontinuity present in that region, right? So I think you're all like it's clear about all above four methods. Now coming to the next point, eddy current test. Eddy current test, it is a type of like it is one of the NDT method which use the eddy currents. Eddy currents is nothing but secondary currents, and it is a type of test which is similar to the magnetic particle test. Generally in magnetic particle test we pass the magnetic fields into the material. Here we pass the eddy currents into the material and we used to observe the interruptions in the flow of electrical currents, right? So you can have a look at here. In eddy current test, electrical currents are generated in a conductive material by an induced magnetic fields, and interruptions in the flow of the electrical currents which are caused by the imperfections or changes in the material's conductive properties will cause changes in the induced magnetic fields. See here we use magnetic fields and produce the eddy currents within the material, and these eddy currents, the flow of eddy currents can be changed due to the imperfection or due to the change in materials property like conductive properties. So these change can be identified by changing the induced magnetic field, right? So this change when detected indicate the presence of change in test object. See, it is a coil. See, it is the setup for eddy current test. There is a coil which releases the magnetic fields, and we place this setup, anti-setup on a conducting material, causes the eddy currents to flow within the material, and these also causes for the flow of some magnetic fields, and these get varied with the discontinuities, like with the presence of discontinuities or with the presence of the change of material properties for conduction, and it can be identified in the it can be identified by the equipment, right? Next, visual testing. Visual testing is it is the oldest and most common NDT method, and having number of industrial and commercial applications. And generally coming to the point of visual testing, it is a type of test which is used to find out the discontinuities by using the naked eyes, like by using the property of visuality. And discussing about the visual testing, every test is a combination of visual test. How? Look at the RT. In RT we used to judge about the materials property, about the materials where about the discontinuities present in the material by observing the film. So here we observe the variation in the film by our naked eye. So it means the RT is a combination of a visual testing, because we are observing with a naked eye, hence it become a visual testing. So the RT is a combination of a visual test. Coming to the point of magnetic particle test, we used to observe we used to observe for the accumulated magnetic particles. So hence it is a combination of visual testing. Similarly, ultrasonic testing, we observe the echoes on a screen, and it is a combination of a visual testing. The ultrasonic testing is also a combination of a visual testing. Similarly, liquid penetrant test and eddy current tests. So examiners follow the procedures ranging from simple to very complex, some of which involve comparison of workmanship samples with production parts. Visual techniques are used with all other NDT methods. Right. Next, special NDT methods. See, up to now we have discussed about the 6 NDT methods which are used most commonly, So here it has given some more NDT methods, like they are microwave testing, ultrasonic imaging, lasers, holography, liquid crystals, and infrared thermal testing techniques, in addition to many other specialized methods. In fact, there are almost 80 different evaluation methods identified as being non-destructive. Right. Next, NDT jobs. NDT, coming to the point of NDT jobs, the NDT field requires or needs well-trained and educated technicians, because they believe the educated and well-trained technicians perform tests better than the untrained and uneducated technicians. So for the past 15 years, the demand for trained and educated NDT technicians has increased. This means that if you want to obtain a degree in a field with more jobs than people, uh, this industry needs you. And so like to get trained or to get be educated in the NDT fields, you can also consult you can also consult us, and here is our WhatsApp number. You can also text, or you can also call, or you can also WhatsApp to this number, and the number is 9676361656, or else you can also mail to our email ID admin@ndtctc.com to discuss about your future. Right. Next, some entity governing bodies. So there are different entity governing bodies, among them ASNT, American Society for Non-Destructive Testing, and CINDE, Canadian Institute for Non-Destructive Evaluation, are the two most certifying bodies in North America. And our online courses meet the requirements of both NDE training. Okay. Next, NDT personal qualification and certification. So, following World War III, before World War, sorry, following the World War II, before the World War II, the NDT is uh, like it is used only as a laboratory, as a laboratory testing. But after the World War II, it moved to it moved to a widely accepted practice, and driven widely accepted practice. So see, look in here. Following World War II, non-destructive testing, or NDT, moved from a laboratory pastime with limited field applications to a widely accepted practice driven by the needs of the space program in its race to moon. And there are many NDT methods were invented and get developed and put into uses. But see, along with the invented methods, the need for trained technicians growed rapidly. And it soon become the apparent that NDT technicians and engineers with suitable training and qualifications were in a very short supply. But there were no colleges for teaching the NDT. So, right, no special places or special colleges which teach the NDT. And here we are belong to the NDT, we belongs to the non-destructive testing and consultancy and training center. Have the material on We have the material online and at our library to satisfy all of the requirements and for sufficient training around the world. Our NDT training guidelines are used around the globe for most technician certifications. So you can also consult or you can also contact us by through phone, you can also contact for this number 9676361656, or you can also mail to our mail id admin of ndtctc.com, or you can also WhatsApp for the same number 9676361656 for more information about the course details and fee structure and some others, right? And means of uniform certification. There are number of reasons for certifying the NDT personnels. 1. Employers have a uniform means of qualifying and ranking technicians. 2. Customers are supplied with a means of judging the quality of a vendor's NDT program. 3. Certification aids in assuring that NDT personnels are qualified to perform assigned tasks. And 4. Technicians have a means of progressing within their profession. Next, value of certification. So a NDT person or a technician should be certified by an certifying body. So even though he has known the work without certification, most of the companies never allows the persons to perform the work because unsatisfied feeling of security among those individuals for whom the testing is performed, and leading to inadequate precautions being taken in product use and unanticipated failure of improperly tested material. So the person who are going to work in the NDT field has to be certified by a one of the certifying body, right? So so and the field of NDT needs, as of in the previously we have discussed the thing that the NDT field requires a well educated trained technicians, right? So that for training and for training and education you can contact for us for this number, and you can also contact in the email for by this for this email ID, right? Thank you.